Electromagnetic waves are used in various ways in everyday life. Let's look at how we decide which waves to use based on their properties, focusing on the waves at the lower end of the electromagnetic spectrum. Low-frequency electromagnetic waves cannot be seen by the human eye and cause no harm to the human body. These waves are infrared or IR waves, microwaves, and also radio waves. They all have long wavelengths and low frequencies. In particular, they all have lower frequencies than visible light, so we won't see or notice these waves being sent around us. But more importantly, they pose no risk to our health, unlike high-frequency waves like X-rays and gamma waves. These waves can safely be sent around the world for various purposes. We don't have to keep them contained. Now let's look at why radio waves in particular are good for sending signals. Radio waves can travel long distances through air. Remember that radio waves are often used to send TV and radio signals from an antenna to homes and businesses. Often these will be miles apart, which means there'll be plenty of opportunity for waves to be absorbed by air and signals interrupted. Thankfully, radio waves aren't affected by air much, so these waves can travel these distances and still carry a clear signal. Also, they can be reflected off the upper atmosphere to move around the Earth. Waves will travel in straight lines, and as we can see, we can't take a straight line from the aerial to the house without going through the Earth. Instead, we'll make use of the upper atmosphere around the Earth. The difference in air density means that this acts like a boundary at which waves can transmit, be absorbed, or reflect from. Different waves will behave in different ways when they reach this boundary, so we use radio waves as they will undergo reflection here. This allows us to redirect the waves around the Earth and reach the house. But what about when we need a signal to go out into space? Well, microwaves will transmit through the atmosphere and into space. This is why we use microwaves as opposed to radio waves for satellite signals. Here we need the waves to be able to reach a satellite in space. In order to do this, they have to be able to transmit through the boundary at the upper atmosphere. So we can't use radio waves as they would reflect here instead. The satellite can then receive this signal and send a new microwave signal to homes and businesses. Let's now look at some other useful properties of microwaves. The frequencies of microwaves mean they can easily be absorbed by water molecules in food to supply heat. This is the main reason we use these kinds of waves in microwave ovens and why we only cook certain kinds of food in them. For example, we can cook a potato in the oven as it contains water molecules. As we direct microwaves at it, they are absorbed by the water molecules, which gain internal energy. This causes a potato to heat up and cook. Is this the only type of wave used for cooking, though? Infrared light is absorbed by most chemical bonds to increase internal energy. Here's an example of a molecule with various atoms bonded chemically. These bonds can absorb infrared waves, which cause them to absorb the energy from the waves. Like with water absorbing microwaves, the molecules gain internal energy and so they heat up. The main difference between this and heating from microwaves is that almost all molecules can absorb infrared waves, while only certain ones can absorb microwaves. This is why infrared waves are used for conventional ovens and electric heaters. So which other useful property do infrared waves have? Objects release thermal energy as infrared light. This happens as warm objects try to cool down and release their excess thermal energy. For example, a rabbit would always be emitting infrared waves. This allows it to release heat and cool down. The hotter an object is, the more waves they will release. This is how we can create thermal images by detecting infrared waves. Ovens and heaters also work by deliberately heating metals, so they release lots of infrared waves. For your exam, you don't need to be an expert on all the properties of each type of wave, but you should be able to recall these basic properties and explain why we might choose a particular type of wave for a given application.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!